Yeah, what is Kubo? Kubo is the first IPFS implementation. Juan Benet made the first commit in 2014 in Kubo, which started not only Kubo, but IPFS, which is pretty cool. Kubo's UX is centered around a CLI, so the users of Kubo tend to be power users. But Kubo also serves as a platform for other developers. So like all the core functionality of Kubo is separated out into libraries that Go developers can use to build other applications. So that's led to a lot of end-user applications and critical infrastructure that runs on Kubo, such as IPFS Desktop, which is a graphical application for IPFS. The Brave web browser embeds Kubo inside of it to route IPFS traffic through Kubo. IPFS Cluster, which orchestrates Kubo nodes to provide massive amounts of data to the IPFS network. The IPFS.io gateways, which serve billions of requests per week in traffic. All of these things are powered by Kubo. So Kubo's ultimate goal is to provide the best technical foundation for quickly building new IPFS products and experiments. We do that by biasing towards development speed. So whenever we need to make trade-offs, we tend to trade off towards development speed. But we will not trade off security and performance since Kubo is so critical to so much infrastructure. But ultimately, we want to enable fast experimentation and catalyze the IPFS community through extreme customization. So throughout the stack in Kubo, all of the components can be customized and extended. We ship cutting-edge experimental features to users and gather feedback from the experiments and remove the ones that didn't work. We share those learnings from those failed experiments with other implementations. And based on all of that, we provide reference implementations of IPFS specs through the IP process.
IRO is efficient IPFS for the whole world right now. It is a new implementation of IPFS that we've been rewriting in Rust from a number of people at Number Zero and a bunch of community contributors. Right now, it's kind of like, what do you mean by right now? Well, back at IPFS Thing, which is an implementers conference that we had in July, we promised a release of IRO in Q4 of 2022. It's Q4 of 2022. So why don't we do this right now? And I'd like to invite a special guest up. I think Dig, my co-founder and CTO, and the person who personally ported BitSwap, all 7,000 or 8,000 lines of it, into Rust, and then made it function, should come up and push this button. Run, Dig, run. We don't have time. Run. So the Wi-Fi in here's been a little shoddy. Do you want to do the honors? Sure. Okay, drum roll. New IPFS implementation. Hey! All right, a high five. That was worth not sleeping for like a month, right? Okay, so I'm happy to announce to you IRO version 0.1.0. It actually worked. It's up on GitHub right now, I hope. Check it. But what is it? It is a new implementation of IPFS, but most importantly, the thing we have gotten with this 0.1.0 release is actual interop with Kubo. So you can BitSwap with Kubo nodes. Our first release is aimed at the cloud, but it actually works great on your laptop. So well, I'm running it right now. Sketchy, right? But like, it's working. We're building it for efficiency, releasing to multiple platforms. There's lots to talk about. We have some great numbers. This one isn't really focused on our numbers, but we're very happy with our throughput in terms of requests per second on small files. We are a very measurement-focused organization, so we're not going to lie to you when we're slower. Right now, if you want to do 10 megabyte files, use Kubo. It's faster. Ad speed, similar deal. We're getting there. But the thing that we really want to highlight for this release is we have a release that's on the board. It's a brand new implementation of IPFS, ready just in time for IPFS camp. And we cannot wait to get you to try and kick tires on this thing so that we can productionalize it. So please head over here, grab a new IPFS implementation, play with it, file bugs. Let's make this thing amazing. Let's add another one to the IPFS implementation stack. Thank you so much.
I'm Alan. Nice to see you and meet you and see you. Elastic IPFS. All right. Elastic IPFS, it's a new type of IPFS peer. It leverages cloud providers whose infrastructure has been proven to be web scalable. So Elastic IPFS is free and open source. It looks like an elastic band ball because it's Elastic IPFS. All right, so this, well, missing an emoji, but fine, that'll do. So what Elastic IPFS does is it separates its read and write pipelines. So the computers that are accepting data are not the same computers that are also reading the data. So we're trying to kind of avoid this problem where we've got this super busy node that's doing lots and lots of things. And it just, yeah, whew, it's busy. Cool. So, wow. I should not use so many emojis, right? So Elastic IPFS doesn't actually have loads to say about writes. Essentially, data kind of comes in. It comes into a service worker that scales out pretty well. That's yeah, or like lambdas, if you know what that is, that kind of thing. And that goes straight into that little square there is a bucket. It's a simple storage bucket, and we put car files. We accept car file uploads, which are serialized DAGs. That's cool. And then this is where Elastic IPFS comes in. What it does is it gets informed that there's a new car in the bucket, and it maintains an index of the blocks in that car, the byte offsets exactly in that car, and which car they are in. So yeah. What happens is that when bitswap, another peer comes along and connects to Elastic IPFS, it bitswaps with that peer by reading blocks directly out of the bucket using byte range requests. And we can do some fun things there, like in car files, when you generate them, blocks that you want to export using UnixFS are normally quite close to each other. So when you do byte range requests, you can actually extract multiple blocks at a time, so you don't have to do separate requests for every block. So that's really cool. And there we go. Yeah, Elastic IPFS is maybe the largest IPFS peer that has ever existed. It currently serves nearly 5 billion blocks, which is pretty rad. It does that with the help of the network indexers. The network indexers help us allow all of those blocks to be available on the DHT. So, okay, this is my favorite graph. We have this checkup tool, and it takes it samples a CID from our collection of CIDs, and what it does is it checks to see if a provider record can be found for that CID. And this is what happened to Elastic IPFS when the indexer nodes were turned on. As you can see, almost 0% of the time, CIDs were no provider records were being found for CIDs in the DHT. And when they were, it was just kind of by chance that someone else had it. And then they got turned on, and it went up to almost 100% all the time, and it's basically stayed there ever since. So that's super good news, and we're very happy with that. So more bad emojis, but what's the future hold for us? Well, like I said, bunch of optimizations. We need to get that spatial locality thing where we send requests for byte ranges that include multiple blocks. We need to sort that out. We want to do some sort of prefetching, like Elastic IPFS is kind of network I/O bound. It doesn't have access to a solid-state drive like other IPFS implementations. So what we can do is when we receive a message for some blocks, we kind of know that when we send those blocks back, the peer that's requesting them is going to ask us for any blocks they link to. So what we could do is like prefetch those and load them into memory so that they're readily available. While that round trip happens, another one can happen there, and we'll sort of hopefully that'll link up quite nicely. And then the third thing is like oversharing, which if you're going to send someone some blocks and you know what links they link to, why not just send them all of the blocks that they're going to ask for next? So cloud agnostic is, we'd quite like, well, the architecture for Elastic IPFS should be transferable to any cloud provider, basically, as long as they can provide the primitives that it needs. So we'd like to see more infra as code repos for other cloud providers. So like Cloudflare are really close to providing all the things we need. Yeah, so hopefully that soon. Last thing there is multi-region. Would be rad to actually run this thing in multiple regions, maybe multiple instances, but we'll see how that works out. So that's Fun Times Future. Thanks very much. If you want to know more, then please come to my talk. It's called 5 Billion Blocks. And then there's another talk from Paolo from Nearform on horizontal scaling of Web3 system to the sky. And that's in the IPFS Implementers track. Thank you very much for listening. And I hope to talk to you all soon. All right, bye.
My name's Alex Potsides. I am aching brain on the internet. I look after the JS IPFS implementation, which I'm going to talk about very briefly because we're running out of time. JS IPFS is the second oldest IPFS implementation, I believe. The first commit, we actually looked at it in the repo the other day, was 2014. It's been going for a long time. It runs everywhere. Like sometimes it's hard to define what JS IPFS is because it's everything. Because it runs in browsers, it runs on servers, it runs in like desktop applications via Electron. We really hope that it's going to be able to run on mobile in a better way than it does right now through like React Native and that kind of thing. This is something that we desperately need some help with. So with your help, it could also be running on mobile. It's widely used. We have about 11,000 downloads a week at the moment. This is up from some 7,000 odd this time last year. If you look at the stats for the Bootstrap nodes, every IPFS node when it starts up connects to some kind of Bootstrap node in order to get onto the network. From the ones that PL maintains, just under 12% of the network is JS IPFS, so that's an enormous number. And we're actively developing it. So we've had 7 major releases, I should say, in the last 12 months, and lots of little patch releases. We've shipped a DHT implementation. We've shipped a Yamux implementation for better multiplexing. We're investing in the connectivity story. So we've shipped an experimental web transport, which allows connecting from browser nodes directly to Kubo nodes at the moment. But we're not done. There's loads of other stuff that we're going to be shipping soon. So we've got a Circuit Relay v2 implementation in the wings. There's going to be a WebRTC transport, which is another mechanism for connecting directly to Kubo nodes. This one's different from the existing WebRTC implementation in that there's no centralized signaling server. It's going to be using Circuit Relay v2 and finding network peers to do handshake exchanges and that kind of thing. I'm hacking on a quick transport right now for Node, which is going to be very exciting. And we want to make IPFS more modular. So part of the whole theme of this camp is this Cambrian explosion of implementations. But like you don't necessarily want to have to re-implement everything from scratch to create a new version of IPFS that's like specific to your use case. So if you look at the libp2p model where everything is very modular and you compose the functionality that you're interested in and you don't use the stuff that you're not interested in, we want to kind of apply that more to IPFS itself as well, which means making things like BitSwap and the repo and UnixFS and maybe alternative file systems as well, just easier to consume and to combine. So a lot more modular. And we're going to rename it. We're going to rename it because IPFS renamed to Kubo. We want to vacate the space to allow other implementations to grow. We'll go into more detail about that at my talk in the implementations track later this afternoon, which you should all totally come to. We're looking to grow the team. So we're hiring. So please come and talk to me if you'd like to help just develop this incredibly interesting technology in an amazingly unsuited language for it. It's awesome. It's really good fun. I'm super excited about the future. But yes, please do come to my talk in the implementations track. It's called the State of IPFS in JS 2022. Thank you very much.
Well, I can talk briefly about IPFS implementations. So we've reached a massive scale with IPFS. We're somewhere in the 10 million to 100 million end users weekly across a bunch of applications. We have hundreds of thousands of weekly active nodes that we can see in the DHT. There's probably many more hundreds of thousands in a bunch of applications that are not connected to the broader network. There's hundreds of protocols relying on IPFS, many of them massive scale networks. There's thousands of applications, thousands of businesses, and so on. So it is definitely past time that we build a very, very robust ecosystem of many implementations. The ones you heard from today are a sample of a bunch of the amazing work that's going on. And I want to remind everybody that protocols and implementations evolve, and they tend to be supercharged by composability and programmability. The HTTP story was that it started with HTTPD, a very simple daemon process and so on. This was before a bunch of the version control that we're used to today, so people were emailing around patches with each other, and then eventually you got the Apache server because you had a bunch of patches on the server, and that led to the Apache server. From there, at some point, they said, hey, great, let's actually create a new name for this because everyone's getting confused. Which version of HTTPD are you running? And that's the transition into creating many, many implementations of HTTP that each tune for different use cases. So Apache 2, IIS, and many others. Around this time, CGI bin started getting very popular. And that paved the way to add programmability and composability to HTTP in the web. That led eventually to bringing HTTP into the programming languages themselves. So we got a bunch of different HTTP client implementations, then HTTP server implementations. At first, they were very complex. They got simpler and simpler and simpler and easier and easier and easier as people really finally understood how to drive HTTP use across the web. And so that led to a massive explosion of the web that we have seen today. So IPFS is following a similar trajectory. We started with a set of implementations. We evolved them over time with a bunch of slightly different use cases. We now went through and renamed them, so there's no canonical main implementation, but there's instead many different implementations across use cases. We've gone through our kind of Apache and Nginx moment. And now we're entering the new era where composability and programmability with programming languages is going to lead to some massive explosion. We don't know what this is going to look like. It's probably going to be a set of you here in this room that are going to define this. So I invite you to think about what's going to be possible. Really excited. I think one extremely exciting project is the IPVM project that is bringing WASM into IPFS. This is when I look back, one of the things that I missed including at IPFS was a VM. And so thank you to all the folks working on IPVM who are going to help bring us into the future. And really, I want to invite all of you to take charge of this and take part of this. Build your own implementations, work with the ones that are existing there, try them out, give feedback, help everybody kind of flesh out and build a much more robust ecosystem. And small plug for finally making IPFS interplanetary. There's some groups working on bringing IPFS to the moon and later on to Mars. And a way that you can get involved is by leaning on workshops, conferences, and of course, camp today. So there's a ton of sessions today. Learn a ton about how to implement things, how to use things, how to giving feedback and so on, and then carry that forward in a bunch of different conferences related to IPFS and online workshops. There's a number of groups forming online, and so we now are developing the proper open source working groups. So if you're interested in working on some component of IPFS, if you're interested in working on some implementation, join a working group or propose one or create one. Together, if we do this well, we can power a huge Cambrian explosion of IPFS implementations and get to billions of users around the world. Thank you very much, and very excited to hang out with you.